Hello.
Hi. We'll start off with 9-point theorem. 9-point circle. This is something that we saw was there in SL only trigonometry, right? That time we did not do the derivation properly, so now we're going to do it. Okay. So I'm just writing the statement of the theorem. Okay, so we are starting with this theorem. We are saying that if A1, B1, C1 are the midpoints of BC, CA, AB, right? Then
Yeah.
let D be the foot of the perpendicular from A to BC, so altitude from A to BC. Then what we have to prove is that D lies on the circumcircle of triangle A1, B1, C1. So ABC is this one, and A1 is this one, and B1 is this one, and C1 is this one. These are midpoints, okay? Now you can have a triangle A1, B1, C1 like this triangle, and you can have a circumcircle also for this triangle, something like this. It's hard to draw, but for now I'll not draw it. I'll just mark the point D. D is this altitude, foot of the altitude, right? You have to prove that D lies on the circumcircle. Something like this is my circumcircle. You have to prove that D lies on that circumcircle of triangle A1, B1, C1.
Circumcircle, not triangle.
The small circumcircle, this one.
Yeah, no.
Try to prove it. We have proved earlier questions like this where one point lies on the circumcircle. So similar idea, try to think of. Okay, any ideas?
Not really, yes. I think if we can prove it both. I tried looking for a cyclic quadrilateral, but that didn't work.
Okay. Let's think about which quadrilateral. We have to prove what? We have to prove which quadrilateral is cyclic. D, C1, B1, A1, right? Right?
Yeah.
Okay. So, in order to prove that it is cyclic, we will have to show that angle C1, B1, A1 plus angle C1, DA1 should be 180, no?
Yeah.
Okay. So, let's think about it. I will join CD now. CD I have joined, and CD, this is the thing. Okay, so look at the triangle ABD. Triangle ABD is right angle triangle, right?
Yeah.
Because this is an altitude, we know, right? And C1 is midpoint of hypotenuse, right?
Correct.
So in a right angle triangle, the midpoint of the hypotenuse is usually the C1 is what? Circumcenter, no?
Circumcenter. Yeah.
Midpoint of the hypotenuse is the circumcenter. So we know that C1 is equidistant from all the three vertices A, B, and D. So C1D should be equal to C1B, no? Right?
Yeah.
So therefore, in triangle C1BD, C1D is equal to C1B. So isosceles triangle, no? Correct?
Correct.
So angle C1BD should be equal to angle C1DB is equal to B, right?
Yes.
So if C1DB is B, then C1DA A1 is 180 minus B, right?
Correct. Correct.
Okay. And if this angle is B, right? We just have to find
Yeah.
out what this angle is, right?
Yes.
And now this C1B1 is midpoint, right?
Yeah.
Midpoint theorem, you know that it is parallel to this, right? So this
Correct.
angle is also B and this angle is C, right?
Yes.
Correct. So what we have is, this is C, then this overall angle is 180 minus C, right?
Yes.
And this angle will be B, right? Because parallel line, again, this is parallel to this, right? So this is B, right?
Yes.
And this is C. So this portion will be it will be A, right?
Correct.
So this portion will be 180 minus C minus A, right?
Yes.
Which is equal to B, right? So this
Yeah.
becomes B plus 180 minus B, which is 180, right?
Yes.
So that implies that this quadrilateral is cyclic, right?
Yeah. Okay.
So understand what happened. So to prove this cyclicity, we have to prove this plus this is supplementary, right?
Yeah.
Then we started thinking about each of the angles individually. What is C1DA1, right? C1DA1 came out to be 180 minus B because the C1 was the midpoint of the hypotenuse of triangle ABD. So C1D was equal to C1B, right?
Yeah.
And this angle is B, so this angle is B. So therefore, the overall angle here is 180 minus B, right?
Yeah. Yeah.
After that, we have to figure out this angle, right? We have to prove that
Yes.
that angle is B. So what we realized was that actually we could have done it much easily. We could have said this is a parallelogram, this one, right?
Yeah.
Because B1 C1 is midpoint of midpoint theorem will apply. So B1 C1 will be parallel to BC, and A1 B1 will be parallel to this, right?
Yeah.
So opposite sides are or parallel. No? This is parallel to this, and this is parallel to this, right?
Yes.
So if it's a parallelogram, then opposite angles are equal. This angle is equal to this angle.
Correct.
Correct, no?
Correct.
So finally, we are getting the fact that this plus this is equal to is 180. No?
Correct.
So basically, right now, what we have seen is that if you have A1, B1, C1 as the midpoints of the sides of a triangle, and if you connect a circle through those 3 points, then another point lies on that circle. What is that point? That is the point which is the foot of the perpendicular of A to the altitude, opposite side, right?
Yeah.
So by symmetry, what you should also have is foot of the perpendicular from B to the opposite one should also lie on the circle, right? You understand?
Yeah.
This should be the thing. And by symmetry, foot of the perpendicular from C to the opposite side should also lie on that side. Correct.
Correct.
So basically, if you have a triangle like this, ABC, and you had 3 midpoints, and another triangle here, A1, B1, C1, then this circumcircle, there will be a circumcircle like this. Drawing it is slightly annoying, but what we know for sure is that this point, and this point, right? This is
Yes.
your D, E, and this is your F, right? We have just now proved that D lies on circle of A1, B1, C1, right? Circumcircle.
Yeah.
So there's nothing special about D altitude. So similarly, you should also have E and F also lie on circumcircle A, B, A1, B1, C1, right?
Yes.
So right now, suddenly you have one circle, which is circumcircle of A1, B1, C1, and therefore you have 6 points on that circle, right? 6 points on circumcircle A1, B1, C1, right?
Yes.
What are the 6 points? A1, B1, C1, D, E, F, right?
Yeah.
Okay. Now, so already we have 6 points on the circumcircle. The next part, if we prove, we will prove the overall 9-point circle theorem. The next part says that theorem 2. It says that again A1, B1, C1, A1, B1, C1 are midpoints of triangle ABC, midpoints of the sides of triangle ABC. Okay, let H be the orthocenter of triangle ABC, right? Let X be the midpoint of AH. Prove that X lies on the circumcircle of triangle A1, B1, C1. So exactly the same question, just a different point, okay? It's the same
Okay.
setup, everything is same. You have A, B, C. A1 is here midpoint, B1 is here, and C1 is here. So you have this triangle. Let's draw the orthocenter. So one altitude is like this. This is your D. Another altitude is like this. This is your E. This is your orthocenter H. midpoint of AH is this point X. Okay. We have to prove that X lies on the circumcircle. So right now already we know that E lies on the circumcircle, right?
Yes.
We already know that things are like this. In part 1, we proved that D lies on the circumcircle of A1, B1, C1. So if D lies on it, E lies on it, and also this uh, hmm, there will be another point where the altitude here lies on it. This point lies on it. The figure is wrong, obviously. The circle should come back and cut it like this, right? But I've not been able to draw it properly. Forget about the drawing. We have to prove that X lies on the same circle, okay? And X is what? X is midpoint of AH. Okay. So
Okay.
we have to prove basically that if you join X with C1 and B1 and this quadrilateral that we can see right now, X, B1, A1, C1, right?
Yeah.
Prove that X, B1, A1, C1 is cyclic, right?
Right.
So in order to prove that, which angles do we have to show is supplementary? We can show this angle plus this angle, right? Correct. Or we
Correct.
could also show another set of angles. This angle plus this angle also we can show. So angle XC1A1 plus angle XB1A1. If that is 180, then also it is cyclic, right?
Yeah.
Okay, fine. So So here x b1 a1. Okay. So first thing that I can see is in triangle ABH. Triangle ABH. You can notice that
Yes.
C1 is midpoint, and also H, the X point is supposed to be also midpoint, right?
Yeah.
Of AH. So
That means that they're like that means that XC1 is parallel to BH.
XC1 is parallel to BH.
And it's also half of BH.
It's also half of BH. So okay. So XC1 is coming out to be, if you remember from triangles, BH is distance of orthocenter from the vertex, right?
Right.
So this will be 2r cos p from SL Loni, right?
Yeah.
You remember that, no? 2r cos p and 2r cos a
Yeah.
cos c, things like that.
Yeah.
So this one will be r cos p, right?
Okay.
Cx1 will be half of that, no? But the main thing is that Cx1 is coming parallel to BH, right?
Yeah.
And BH is perpendicular to AC, right? Correct.
Yes.
BH is perpendicular to AC. So therefore, technically you can say that C1x will also be perpendicular to AC, right?
Yes.
Now we know that C1A1 is parallel to AC, right? C1A1 is parallel to AC because again C1A1 is midpoint theorem, right?
Yes.
So therefore C1x should be perpendicular to C1A1, no? Because AC and C1A1 are parallel, right?
Correct.
So C1x will become perpendicular to C1A1, no? Correct?
Yes.
So this angle is coming out to be 90, right?
Yes.
Correct.
Correct.
So now let's think about XB1A1, right? XB1A1. Correct. Again,
Correct.
if you look at the triangle, this sort of triangle, this triangle, right? AHC, right? Again, XB1 is midpoint theorem there.
Yes.
XB1 is parallel to CH, right?
Yeah.
Okay. And we know that CH is perpendicular to AB. CH is perpendicular to AB, right? Because it is
Yeah.
the line joining orthocenter, right? So CH is also perpendicular to then B1A1, no? Because
Yeah.
B1A1 is parallel to AB, right?
Yeah.
So if CH is perpendicular to B1A1, so XB1, which is parallel to CH, is also perpendicular to B1A1,
Yeah.
right? So this angle is also 90. So
Right.
what we have suddenly is two opposite angles are 90, right?
Okay.
Are you understanding?
Yeah, it's making sense.
So basically what we have is X, B1, A1, C1 is also cyclic. And
Yeah.
the reason is just purely by following the angles and noticing many different midpoint theorem situations, right?
Yep.
You are able to say parallel lines, perpendicular lines, and figure out that these angles are 90 and 90. Right?
Okay.
Just write down this part. Now we basically have a situation that there are 9 points which lie on the circle, right?
Yeah. Okay. Just give me like
Yeah.
3 minutes to write it down.
Yeah. Have you written down?
Yes.
Okay. Then with theorem 1 and 2 combined, what we have is in the triangle ABC, we have these midpoints A1, B1, C1. We have the foot of the perpendiculars B, E, and F. And we have, if this is the orthocenter, we have midpoint here, X, midpoint here, Y, and midpoint here, Z, right?
Yes.
So we have these points 1, 2, 3, 4, 5, 6, 7, 8, and 9. And 9, right? These points
Yeah.
all lie on a circle. So that circle is called a 9-point circle.
9-point circle.
And this circle is actually the circumcircle of A1, B1, C1, right?
Yeah.
Right. The circle is
Yeah.
the circumcircle of triangle A1, B1, C1. So if
Yeah.
you join this triangle like this is the circumcircle. Okay.
Yeah.
So circumcircle is this. So can you find center and radius of the 9-point circle? This circle is called 9-point circle. And can you find the center and radius of this? Right? So think about it. So let's say you have O is the circumcenter of triangle ABC. Okay. So circumcenter would be from perpendicular from A1, right? And from B1, right?
Yeah.
This is O, let's say. And this is your orthocenter here. Correct? Then
Correct.
X is midpoint of AH and D is the foot of the perpendicular from of altitude. Then you remember we had derived earlier in the previous class, but that AH, this distance AH, right, is 2
Yes.
times this distance, right? OA1.
Yeah.
We had done earlier in previous class AH is equal to 2OM, where M was called this point, right? So right now we have AH is equal to 2OA1, right?
Yes.
Correct. And if we
Yes.
join H and O, and if we join this midpoint and this X and A1, right?
Yeah.
If we join it like this, then we get a congruent triangle. This triangle and this triangle will be congruent because they are already similar, because this is parallel and vertically opposite. They're already similar, right?
Yeah.
And by chance we have that XH is equal to half of AH, which is equal to OA1, right?
Correct.
Correct. So basically triangles are congruent. Therefore, what we know is that XH is equal to OA1 and XH, so the sides are equal and parallel, no? So this is a parallelogram, right?
Yes.
HA10 is parallelogram, right? Correct. So,
Yeah.
so the intersection point of its diagonals, right? Correct.
Yes.
Is also midpoint of the diagonals, right? This point
Yeah.
is midpoint of the diagonals. Call it S. So we know that HS is equal to SO, and we know that XS is equal to SA1, right?
Yeah.
Correct.
Yeah.
Now, D, A1, and X lie on the 9-point circle, right? D,
Yeah.
A1, X lie on 9-point circle. Therefore, 9-point circle is like circumcircle of triangle DA1X, right?
Yes.
9-point circle is circumcircle of triangle XDA1, right?
Yeah.
So if it is circumcircle, notice that this is a right angle triangle. So midpoint of hypotenuse is going to be the circumcenter, right?
Yes.
So hypotenuse is XA1, right? Hypotenuse is A1X. So midpoint of that is S, right? S point, right?
Yeah.
S point is also known as the midpoint of H and O. Orthocenter and circumcenter is midpoint, right?
Sure.
Correct.
Yeah. Yeah. Correct.
So midpoint of OH is the center of 9-point circle, right? Center of 9-point circle is midpoint of OH.
Yeah.
The reason is that we got that this triangle is right angle triangle, and we know that S is the midpoint of XA1 because XHA10 is a parallelogram. Therefore, diagonals bisect each other. Why is XHA10 parallelogram? Because opposite sides XH and OA1 are equal and parallel.
Yeah.
Right? Why
Yes.
is it equal? Because XH, this triangle is congruent. There's a congruent triangle situation happening. XHS and OSA1, right?
Yes. Yeah.
And that came because we had AH is equal to 2OA1. AH is equal to 2OA1 from last class proof. This is double of this, right?
Oh yeah.
And therefore, XH is equal to OA1. That became equal, right? So from
Oh
all
yeah.
of these steps, what we are getting is midpoint of OH is the center of the circle, and radius of the circle will be what? Now SX is mid segment in triangle HO, triangle HOA. If you think about it, this triangle, yeah, because if you think of this HOA triangle, right? X is the midpoint of AH, right? And S is the
Yeah.
midpoint of OH, right?
Correct.
So SX is midpoint of OA, no? SX is mid segment, midpoint theorem sort of a line in triangle AOH, no?
Wait. 1 minute. There's no point M in the figure. Where is the point M in the figure?
Why are you thinking of M right now? We are calling A1 as M. This doesn't matter.
Okay, continue then.
How are you suddenly thinking of that? I'm talking about something else. You're paying attention to something else.
Yeah. Listen to how A1 makes a nano boss con
Right now, what are we doing right now?
AOH. You're talking about the triangle AOH, right? And
Why are we doing this?
how SXH is similar to AOH. So you guys can so you can find the radius, right?
SX line is mid segment.
Yeah, it's mixed segment using the midpoint theorem. Yeah, I know what you're talking about.
So SX is parallel to OA and SX is equal to half of OA.
Okay.
Right?
Yeah.
So SX OA is capital R in the triangle. O was the circumcenter. So SX is coming out to be a capital R by 2. Right?
Yep.
And S was circumcenter of the triangle DA1X, or basically S was center of the 9-point circle or 9-point center. So S to X is 9-point radius, right?
Yeah.
Sx is 9-point radius, or R dash is equal to R by 2. So what we have proven is 9-point center is the midpoint of orthocenter and circumcenter of the original triangle, and 9-point radius is half of the circumradius of original triangle.
Okay.
Combining this with the previous class when we proved that orthocenter and circumcenter are bisected in the ratio of 2:1 by centroid, right?
Yeah.
This is orthocenter and this is circumcenter. We proved this in the previous class, that this is divided in the ratio 2:1. Now we have another new thing, that this distance is divided in midpoint of that is called 9-point center, right? So we
Yeah.
have 1:1 here. NH should be equal to ON. So there are four points of the same line. What 4 points? Orthocenter, 9-point center, centroid, and circumcenter. Right?
Yeah.
So if you draw the line points like this, H, N, O, somewhere here there will be centroid. So if you call the whole length as 6 units, you should have 4 units here and 2 units here and 3 units here and 3 units here, right?
Right.
You need to be familiar with these ratios. All 4 points are collinear, and what is happening is they lie on the same line, and this is the ratio in which it is divided. So if someone
Yeah.
gives you, say, HO, you should be able to find HN. Or if someone gives you HN, then you should be able to find what is OH, right?
Yeah.
And even if someone tells you NG, you should still be able to find stuff, right? Because right now from here, it seems like NG and OH, there is a relation, right? Like if you put this at 0, 0, N was at 3, 0, and G was at 4, 0, and this was at 6, 0, right?
Yes.
Right. So if
Yeah.
NG distance is given, that is 1 unit, then the overall is 6 times that, right? Correct?
Yeah. Yeah.
If you know the ratios, then many things will be clear. So this is combining all of the stuff that you did in last 2 classes and today's class. So this is the end of this topic, 9-point circle topic. Okay.
Okay.
After this, we will do 2-3 more things and then we will stop.
And then what will we do after geometry?
Algebra. So in algebra, so 2-3 more things. So probably by end of August we'll stop geometry. Right now, do you know have you seen your exam papers and all? What topics are common in algebra? Like equations, obviously.
Yeah, okay. Sure, I'll ask you. I'll tell you. So I took 3 test papers from this week, which is Monday, Tuesday, and Wednesday. I took 3 test papers this week. I took 1998 AHSMA, 1999 AHSMA, and 2000 AMC 10. So from what I saw, they usually ask stuff about curves and graphing a lot. Like, I'll give you an example of a question that was asked. This was from 1998 HSMA. How many? Wait. A parabola has vertex at 4, -5, like the point 4, -5, and has 2 x-intercepts, one positive, one negative. If this parabola is the graph of y equals ax squared plus bx plus c, which of a, b, and c must be positive?
Okay, this is a very easy question. So we'll do curves and parabolas and all. So I will do conic sections, where basically we'll focus on parabolas, ellipses.
And they also have a lot of log questions. Not the AMC 10 I took yesterday, but the logs. But in the AHSME they have a lot of log questions because AHSME is AMC 12. So.
Okay, what else? What else are problem topics?
Okay. Well, there's this one question. It was a 24th question for 2000 AMC 10. Let f be a function for which f x by 3 is equal to x squared plus x plus 1.
Wait one.
Find the sum for all of all.
F of x by 3.
Yeah, is equal to x squared by x squared plus x plus 1. Find the sum of all values of z for which f3z is equal to 7.
Like this.
Yeah, I think it's a pretty basic reduction of polynomial question, I think.
All values of z for which this is true.
Yeah, sum. They want the sum of all values.
Okay. Sum of all values of z for which this is true. Anything else? What else is said in the question? F is a what? Let f be a what?
F be a function for which that was like the first part, the first piece of information they gave you.
Okay. X by 3 is written like this.
Yeah.
Okay. Fine. So the function is given only, then what is the big, like, I don't understand what the problem is. We have to write this in terms of x by 3 first of all.
No, it's not a hard question. It's just a question.
You got it, right?
Yeah, I did.
So fine. So what are there more questions where they are saying let this be a function and all? Are there many function type of questions?
Yeah, actually they do ask a lot of function questions from what I said.
Okay, so maybe we'll do a little bit of calculus, which is functions, or pre-calculus you can call it. What else? What other topics are there which you don't know right now, which are difficult? You have done 3 papers, so you must know.
I'm just giving topics. I did a lot of algebra last year when I was preparing for AMC 10. So I think I just need to advance. The only thing I actually consistently need work with as of now is log, because I have a lot of trouble with that.
Okay.
Does recursion technically fall in algebra or not? Because there was this question. It's from an earlier test I took.
What?
It was consider those functions f that
Just hold on
satisfy
for a second. What thing fall into algebra? What are you saying?
recursion.
Recursion, yeah, you can call it algebra only. Yeah, recursion, you should look at AOPS book. AOPS volume 1 you're doing, right?
Yeah.
There will be a chapter on recursion, I think, somewhere. It should be a chapter in counting or somewhere in the book. So, okay, fine. So what we will do is we'll start off with these things. We'll do equations first because equations will be useful even in conic sections and everywhere. Equations, conic sections, logarithms, and then we'll do other topics. So these are the things that we'll do. We'll start off this possibly in last week of August or first week of September. Okay. Just like what you should do is when you are doing practice papers and all, just make a note in your diary about the kind of questions that are troubling you, or go through whatever practice papers you have done and make a note of what is happening in multiple year papers, what is it that bothers you the most. So
Okay.
whatever those topics are, we will focus on them first. After
Okay.
that we'll go to other things. So, and if you have made a note, like if you have done 5-10 years papers, no, you should get a fair idea of which portions you are strong in, which portions you are weak in, right? So
Yeah.
just make a note of all the weak topics, make a list, send that list to me. We will do those things first. Okay.
Yeah. Okay, I'll see you.
Like make a comprehensive list, like do what, see all the 10 years of whatever AHSME or AMC 10 exams you can find and solve as many as possible, and you will get a comprehensive list of what topics have come which have bothered you and which have not been solved and which you need to learn, right? So we'll just focus on those things in September and onwards as we go.
Yeah. Okay.
Okay, bye.
See you. Bye.